We're going to keep reviewing a little bit of parts per million, parts per billion. So if you look on the board, you will see two problems. The first one says contaminated water has a lead concentration of 14 parts per million. And the question is, if you have 2 kilograms of water, how many grams of lead are in the sample of water? Second question is, your mom tells you that you're 1 in a million, 1 ppm. If there are 7 billion people in the world, 7.7 billion people in the world, how many people are just like you? You'll notice here for the two problems, the first one has units of grams, kilograms, stuff like that. The second problem, instead of using units like grams, you want to use units of people. So it's a little bit different than what we've technically talked about. See if you can figure these out. Go ahead, pause the video, and try them on your own. Great, so hopefully by now you've tried these problems and you've got the answers 0.028 grams and 7,700 people. Those are the two answers. Now, if you got both of them, great, congratulations. If you didn't get both of them, let's talk about how to solve these problems. These are a little bit more difficult than some of the problems you would see on your homework. So let's kind of walk through them, let's try them out. Okay, here's the first question. And here, remember with parts per million, there's two equations we can use. On the one side, we can use ppm is solute in milligrams divided by solvent in kilograms. Solute in milligrams divided by solvent in kilograms. That's one way. Or we could do solute and solvent, but they're both in grams, and then you have to multiply whatever that quotient is. You got to multiply that by 1 million. I think that's right. An answer of two numbers divided by each other, that's called a quotient, right? That's a flashback to math. Anyways, so of these two equations here, notice that I've got solute here. I've got them in different colors, blues, and solvent in different color greens. So when we're actually looking at the problem, you'll see here that our concentration is 14 ppm. That's purple. But then our 2 kilograms of water, that's a solvent number. And I put it in dark green because our solvent is in kilograms is dark green. But then you'll notice that the question asks how many grams of lead are in the sample of water. So that's a light blue. So that's kind of following this equation, the second equation. So you'll notice that for one of these numbers, it'd be easier to use one equation, and for the other number, it'd be easier to use the other equation. So in this case, it's really up to you. What are you more comfortable with? Either way, you're doing at least one conversion. So I'm going to show you guys both ways. Here's how you start it off if you're doing milligrams and kilograms. On the left side here, you're going to plug in those numbers just like that. Or if you're doing grams over grams, 14, 2,000, and then times 1 million. Now, either way, in either one of these problems, you want to isolate your blue solute here. For the milligrams one, all you have to do is multiply by 2. So that's kind of easy in terms of the math. For the other one, the light blue one, solute in grams, you're going to have to multiply by 2,000 and then divide by 1 million. So here we go. Now, you'll notice here that on the left side, our answer is going to be in milligrams. And on the right side here, our answer is going to be in grams. We wanted grams of lead. So this is not a final answer here. 28 milligrams is not our final answer. We need to convert that back into grams by moving the decimal place over 3 times or dividing it by 1,000. So that's how you get 0.028 grams. When I first tried this out, I just thought the answer was 7. Please make sure you're using this formula and you're kind of thinking through these problems because they can get a little tricky. Sound good? All right, here is in question number 2. It says your mom tells you you're 1 in a million. If there are 7.7 billion people in the world, how many people are just like you? Here, remember, these units are no longer grams. Now we're dealing with people. So if we were to kind of convert the first kind of shortcut equation, it would be solute of millipeople divided by solvent of kilopeople. We don't have millipeople and kilopeople, we just have people, right? There's no such thing as 1/100th of a person or 100 people groups. So here, the better option is going to be to use this second equation here, where you're going to have to multiply by 1 million. So once again, we're solving for solute. We've got a number for ppm and for solvent, so go ahead and plug those in. Same thing as before, we're going to divide and we're going to multiply the 7 billion number, divide the 1 million number, and then when we do that, we get our 7,700 people. So that's a quick review of parts per million. Hopefully you got these problems right. If not, hopefully now you see how to get these problems right. Let's move into percent by mass. This should be kind of quick here. Percent by mass is very straightforward. Honestly, the most confusing thing about it is all the other names it can be called. Percent by mass could be called percent concentration, percent by weight, weight by weight, or mass by mass. And then it could also have those abbreviations W/W, M/M. These are 5 different ways to say the same thing. They all say percent by mass. You can use this to determine the percentage by mass of the solute in a solution. So remember, a solution is made up of a solute or a solvent together. So really what we're looking at here is how much weight is the solute of the solution. That's kind of what that thing is saying right there. So it's just a percentage is all it really is. Remember, solution is solute plus solvent. That'll come into play once we start looking at the equation. Fun fact, toothpaste is about 1% fluoride by mass. Fun fact, just in case you were wondering. Okay, let's get into the equation. This is what you're going to have to feel comfortable manipulating. Now, percent concentration can be written in a couple of ways. Here's one of the formulas here. We have percent concentration equals grams of solute divided by grams of solute plus solvent. So right there, that kind of looks like finding a percentage, right? You're taking your grams of your solute and you're dividing it by solute plus solvent. Do you guys remember what solute plus solvent is? It's solution. So actually, if you look at this second equation here, you'll notice that it's solute divided by solution times 100%. These two equations are exactly the same. It's just one kind of broke down the solute and the solvent. That sometimes makes it a little bit easier because sometimes you're just given the weight of like the water and you'll be given the weight of the solute. In that case, you want to use this first equation, solute and solvent. Water is a solvent, not a solution. Now, if we say we give you the weight of the solute, like we say you got 15 grams of salt, that makes a 100 gram solution. Now you're dealing with solute and solution. So you want to use that second equation because in that solution number is the 15 grams of salt in this case, plus then the 85 grams of water. That would be if you broke it apart. So you would just use that 100 number as the solution number. Here's a question right here. Let's go over it together. So it says, if you have 30 grams of H2O and 10 grams of HCl, what is the percent by mass of HCl? So why don't you guys take a moment and try this problem out on your own. See how you can do. Ready, set, go. Great, so hopefully you took some time. Hopefully you've got this problem solved. Let's go over it. Great, so first thing we notice here is that we're gonna want to use solute plus solvent equation here because we've got grams of H2O, that's our solvent, and we've got grams of HCl, that's our solute. So 10 goes on the top and it goes on the bottom plus 30. In this case, our grams of solution would be a total of 40. So when we divide 10 by 40, that gives us 0.25. Then we multiply that by 100%, and that's how we get 25%. So we would say that this is a 25% by mass solution of HCl. That's how you solve the problem. Here are 2 more example problems. I'd like you guys to go ahead and try them on your own. Notice here that these 2 problems are exactly the same. The only difference is one says solution, 100 grams of solution. The other one says 100 grams of water. So try these out, see how you do. Hopefully you solved them. If not, pause the video, keep going. Here are the answers. I'm going to start by giving you guys the answers because I think this is kind of cool to see. The first one is 15.6%. The second one is 13.5%. So right away, these don't have the same answer. And again, that's because of the word solution versus water here. When we're talking about solution, we're going to use this first equation, grams of solute divided by grams of solution. So in that case, it's just 15.6 divided by 100 times 100. That's how we get our 15.6%. In the second one, it's saying 100 grams of water. So what that means is water is not a solution. Water is a solute, or a solvent, sorry. Water is a solvent. So our formula here is going to be grams of solute divided by grams of solute plus solvent. So the number on the top here is still 15.6, but the number on the bottom is not 100, it's 100 plus 15.6. So you're taking the same top number, but you're dividing it by a bigger bottom number, so your concentration is going to be lower. And the answer that it spits out is 13.5%. Hopefully this made sense. Problems like this will show up on the test, just so you're aware. We will ask you two identical questions, use solution for one and use water for the other, and see if you guys remember the difference between those two equations. When do you just plug the number on the bottom? When do you need to plug the solvent plus solute number on the bottom? Hope this helps. Hope you guys had a great day, and take care of yourselves and try out the review. Thanks so much. Goodbye.